We experience the world around us through our five senses. The internet is pretty awesome too, but the internet and reality have a hard time working together. Thankfully, this is changing quickly. With six sense tools, we can see the world around us with a layer of information. This is known as sixth sense. A very good morning to all present. Springdales School, Pusa Road presents Sixth Sense, integrating information with the real world. If you have ever seen a movie with a fighter pilot, you have seen the pilot's view from the cockpit. But something's missing. The pilot needs a layer of information that add useful items to his view of reality. Recently, this kind of information showed up working on your smartphone. But instead of flight data, you have data about the world around you. Let's say you are hungry at a busy intersection. There are multiple restaurants around you, but you don't have a good way to make the decision. Now, thanks to new softwares on your mobile phones, you can simply point your camera at buildings and around you, and voila, the buildings are magically recognized and information about the restaurant appears on the screen. It works by finding buildings near itself using GPS and compares what it sees to the images of buildings around it from the internet. The main challenge in this process is the matching of images of objects or buildings. Similarly, repair aiding programs compare standard images of machine parts with what is present in the scene to aid users. Let's see how this comparison is done. The algorithm works by finding key features in two objects being compared. If key features are similar to each other, then the two images are likely to be similar. Key features are present around corners. These can be further described by describing the general orientation of brightness of gradient around the point. To this, the local orientation is calculated for all pixels around the key point. Then a histogram is created for this. In this histogram, the 360 degrees of orientation are broken into 36 bins, each of 30 degrees. Let's say the gradient direction at a certain point is 18.759 degrees. Then it will go into the 10 to 19 degree bin, and the amount that is added to the bin is proportional to the magnitude of gradient at that point. Once this is done for all pixels around the key point, the histogram will have a peak at some point. Here you see the histogram peaks at the third bin, so the key point is assigned orientation 3. Also, any peaks above 80% of the highest peak are converted into a new key point. This new key point has the same location as the original, but its orientation is equal to the other peak. So now we have key points for both the images to be compared. If key points are similar to each other, then we can say with confidence that they are the same object. Augmented reality programs in the future may also recognize the faces of people they see, display information about them to the user. Many techniques have been developed for recognizing faces. One such technique involves finding the displacement vectors between key features in the face like eyes, ears, etc. They are compared with the displacement vectors in the facial images in the database. If a high degree of similarity exists between two faces, then it is probable that the two belong to the same person. The main advantage of this system is that a lot of complex information about a face is reduced to a few basic points. But it also faces a disadvantage. It cannot accurately handle faces that are not facing the camera. Let's look at some of the applications of this technology. Consider this navigation program, which overlays the route to be taken by the driver over real-time video from the camera. The device gets its appropriate location from GPS, and final position is calculated by detecting the edges of the road, which are detected by looking for lines that border a grayish blob. It then overlays the correct route on the video. Next, take a look at this pedestrian navigation system, which recognizes buildings using the technique we discussed. Note that it does not need to do a full feature comparison once the objects are recognized for the first time, as the object is unlikely to move this drastically between frames. It is sufficient to look for a feature in the next frame near the feature in the older frame. Thus, tracking becomes a lot computationally intensive. It then overlays this information over the video to give the user information that would not have been so easy to get without the aid of 6th Sense technology. 6th Sense is also used to guide novices in conducting otherwise complex repairs. This also recognizes objects by comparing their features against the database and displaying appropriate signs to guide the mechanic. As we can see, 6th Sense technology has a lot of potential in the future. It can greatly enhance our productivity so we can do more in less time. Thank you.